STEM revision video on further maths. We're doing matrices today. My special guest, Kieran Bickell. He's on the show. Okay, so first of all, we're going to be doing finding the determinant of matrices and then inversing them, and then we're going to multiply them together. Okay. Inverse matrices. So you want to find a to the minus 1, or 1 over a. I know we're going to do that is you first of all times the top left by the bottom right if it's a 2 by 2, 1 times 4, put it in brackets, and you subtract top right and the bottom left, minus 2 times 3. That's 4 minus 6, which is minus 2. Minus 2 is the determinant, and so we can call that det of a. And so what this means is that 1 over the determinant of a, which is minus 2, is what we times this matrix by to get the inverse. There's also another step. We have to reverse the top left and the bottom right. So that'll be 4, 1. And we have to make these, the bottom left and the top right minus. Minus 3, minus 2. Times it together. So that's minus a half times by 4 is minus 2. Minus a half times by minus 2. That's positive 1. Minus a half times by minus 3 is positive 1.5. And minus a half times by 1 is minus a half. And that is an inverse matrix.
Multiplying these two matrices together, we'll just go straight to it. The top left here, the 1, is multiplied by this top 5 to get 1 times 5. Then add here the top right with the bottom one in this case, so 2 times 6. We then go down the level to the 3, multiplied with the top again, so 3 times 5, and add this to the 4 times the bottom again, so 4 times 6. Close that off, and this is then equal to 17 and 39, and we round those brackets off, and that is your multiplied matrix.
Okay, so we're just going to show the formula for multiplying matrices. If you've got a 2 by 2 multiplied by a 2 by 2, there's the brackets are square instead of circular this time, because if the amount of columns is equal to the rows, it's a square bracket. So you start with timesing the top left by the top left, a times e, and you add together on that the top right times the bottom left, b, g. Then you're going to do a times f, the first row times the second column. You add b times h, top right, bottom right, c times e, d times g, and you see the pattern c times f plus d times h. And so this only works if the amount of rows is equal to the second amount of columns. So it'll work with this one, okay, because columns equals to rows. Whereas if you had like a 3 by 3 times a 1 by 1, it just doesn't work. And so that's the multiplied matrix.